just a link, eh?
Yes, I will do.
Okay, thank you.
Okay, cool. Thank you,
Okay.
Bronwyn.
All right, have a good day. Bye.
Bye. Okay, hi guys, let me quickly post the attendance register and then we can start. I hope you can get into it. If not, we will make a plan again later. Can you guys see the presentation? I can you guys see it?
Yes.
Okay, cool. Okay, awesome. Okay, so I just want to get to where we were last time, and then we can just continue. So let me quickly see. Okay, so basically what we are covering today is more of a differentiation and just the areas of nearly where we go back to. Let me quickly I want to get to, so we're just covering a bit more of this part of the section in study unit 6. Just want to get some of the terms and things out of the way, and then hopefully we will have time to start with integration as well. Next week, I think we're going to have a much longer session to just catch up on some time that we've lost last week. And then in next week's one, I actually want us to finish everything so that we can hopefully still schedule in the week that you guys are writing 1 or 2 sessions. So hopefully you're not writing anything else in that week, but I will communicate that on the WhatsApp group as well, so that we can just get more time in. Okay, so basically what I want today again is, and you would have seen it in your assignments as well, that there's a lot of the times where they talk about, they tell you that you have a total revenue function, or they just give you a demand function. So they can give you the demand function. I think we, in one of study unit 2, I think we looked at something like this, and we originally thought it was a straightforward one, but then they give us the demand function, but for total revenue, we always need to nearly remember that the formula for that is P times Q. So we do have the P, but to get to the total revenue, you still need to times it by Q. And I will just need to make that really a 0, that it doesn't look like 106. Okay. So then automatically when we times it by the Q, you will see that now suddenly we will sit with a quadratic function. Okay, and then if I start asking you the next set of questions, like marginal revenue, we know that marginal revenue is when you differentiate total revenue. So marginal revenue would be this formula differentiated. So basically Q is always Q1 if there's nothing. So Q1 minus 1 will fall away. So we will have 100 left. With this one, the 2 goes in front. So 2 times 2 is 4. And it will be 4 and the Q. Okay. And then they would also need to tell you. So do they say, well, that marginal revenue, you need to work out what is the quantity where it's the turning point, and if it's the turning point, we know it's equal to 0. They can also tell you, well, my total revenue or my marginal revenue is equal to 100 or 200. So whatever they tell you, then we can calculate the Q. And if we have a Q, we can then put it back into this original formula to get to the P. Okay, so nearly want to show with this that just with the demand function, you can get to your total revenue, and from your total revenue, you can get to your marginal revenue. So the other thing that they can ask you to do, and they can say to you, but okay, now that you've got your marginal revenue, you need to work out what is the second derivative of that. So that just basically means that you're going to do another differentiation on this equation. So if you do another differentiation on this, you know that when there's a constant, it falls away. Here is still a Q, but that will now also disappear. So if you do another differentiation on this, the answer will be minus 4. Okay, so that is just basically to show what is possible. But just by giving the demand function, they could have asked you to work out the marginal revenue. So that for me is just, they don't need to give you all of the information because you nearly have it. So that for me is just the point that I nearly wanted to make. And you can see the next one, very similar, but now they start to throw in your log or your lin. Okay, so the demand function again they give to you. So if we need to get to marginal revenue, we first need to get to total revenue. So total revenue will be that times Q. So multiply that in there, multiply that in there. So your And let's just add it, your total revenue. So remember now one thing, that log is sitting on its own there. So when you multiply that in, you don't change anything to the log. Okay, so it's not that now suddenly it becomes log to the power of 2 or anything like that. You multiply it with the constant, which is the 6. Okay, so that I think is the first thing that is very important. So that now is your total revenue function. Okay, so now it nearly the things that we did two weeks ago. So now if you need to work out the differentiation on this, we need to remember what rule we need to use. So firstly, we've got two terms. So when you've got the two terms, you will need to start using the product rule. Okay, so let's quickly see if it is that easy just to do that. So when I do the differentiation of that, it becomes 24. So that one is quite easy. So let's see if this is a simpler way to write this. Okay, so because I need to differentiate 6q minus times ln of q. So now, is there a way that one can make it easy? So what they did there is they basically okay, so let's use the product rule for this. So what does the product rule say when we will look at this term? Okay, so the product rule says, and it doesn't matter which way you do it. So let's just say it's for one times the differentiation of the other one, plus then just the opposite. So let's make it, I take the 6q times I'm differentiating with ln of q. So what is the differentiation of ln of q? Can you guys remember differentiation of ln of q? Okay, so ln of q is 1 over q. Okay, so somewhere in your log have, what was it, ln of x will become 1 over x or something like that. Okay, so we've done that. So the other one is to say, okay, well, we differentiate 6q. So we know that there's a 1 there, so 1 minus 1. So we're sitting with 6q times ln of q. Okay, so let's just see what they did here is they automatically took out the 6 before they started. So that we could have done as well, because you can see 6 will be in both. So let's also do that because it makes it sometimes easier to work without without the 6 into that you don't. So let's see if we then still have the same. So I just did it the other way around, but there is that one, and there is that one. And again, it doesn't matter which one you want to do first. Because it's a product rule, there is no right or wrong which one you want to differentiate first and multiply by the other one, as long as you just remember to do the same then again with the rest. Okay. And you would now see that if you do that, so let's keep it 24 minus 6. So this should actually, if you write it better, I didn't know there would have been something like that. It is Q over 1. So Q over 1 times 1 over Q is 1. We are left with ln of Q. And then basically you look at what is the answers that you are getting as for options. So that could be one of your final answers. It could have been that you just then multiply the 6 back in. And if you do that, just remember that you need to simplify that. So that could have been also one of the final answers. So that is basically the marginal revenue, or the marginal revenue formula. So now again, they need to tell you, okay, am I going to assume that this marginal revenue will be equal to 0, or is this marginal revenue equal to something else? If I don't tell you anything, we assume it is where it's equal to 0. So if I want you to basically solve it, we will make it equal to 0. Then it becomes that we just move the terms around a bit. Then we can divide by 6 on both sides. So ln of Q will be equal to 3. And then again, to basically go back to our rules. So if we have that, we need to remember how to solve it. Is basically you can, on both sides, how you do it is to make it e to the power of. So the thing that they now left out here is you would say e to the power of 3 equals to e to the power of 3. And by doing that, you are basically making it equal to Q. Okay, so that is the nearly a step that they have left out, is when you e to the power of something, when you do it with ln, it basically means that it actually falls away. So you will have e to the power of 3 is equal to e ln Q. So the E3 will be equal to Q. Okay, and then e to the power of 3 will be able to work it out on your calculator. But again, it all depends on what they want you to solve in the exam. If I only want you to solve the marginal revenue function, you would have stopped at one of these points. If I wanted to you to work out how many units must be sold so that you maximize your marginal revenue function, then you need to work out Q. So it all depends on basically what the question is. Okay. But this is nearly an example of the differentiation that is linked to the first two chapters. And that is why it's always one starts at the first two chapters, because if we only start here, then it's nearly one get lost in all of the work. The other thing that we have in this chapter is nearly they can ask you to do a few things. So they can ask you to work out turning points. They can ask you to work out where the maximum and minimum turning points are. They can ask you to work out a curve with where does it go through the x-axis. So there's a few things that they can ask you from this information. So nearly all that I wanted to show here with this part that's in your textbook is to say, okay, sometimes they give us the, what is that, cube, so to the power of 3 function. So if I give you that, you still follow the same principle to say, okay, but if I need to get to my turning points of that function, I will need to work out the first derivative. Remember when it was this function, when we needed to work out the turning point, we took the first derivative. So even though this is to the power of 3, your first derivative will give you your turning point. In this instance, it will give you 2 turning points, but it will still give you your turning point. And I think that is important. So your first derivative of any equation that they give you is your turning point. And I think how you need to nearly remember it, and I'm going to use, so you don't do this, but if it was t to the power of 4, you would have had 3 turning points. So basically look at it as 4 minus 1 because it's the first derivative. When it is t to the power of 3, you will have 2 turning points. When it is t to the power of 2, you will have 1 turning point. If it is t, then it is a straight line, so it actually don't have any turning points. Okay, so that is just to nearly say, look at what your exponential sign is so that you know how many turning points there will be. Okay, so, and then we take the first derivative. So the 3 goes in front, so that turns to 2. The 5 goes into the front of the 2, so 2 times 5 is 10. That becomes 1, so we can take that away. There is 1 there, so the 1 times the 9 stays 9. That becomes 1 minus 1, so the t disappears, and the constant will always fall away. So now you can see, when we go to the bottom here where they have done it, 3 divided by 3 is 1, so we are left with t to the power of 2. There we have minus 10, and it is minus 10t, and there we have the plus 9. Okay, so that was the first derivative. Then from that first derivative, we now know that there is 2 turning points. So we need to factorize this equation to get to the 2 turning points. So when I look at this, I always try to see if I can't do it without the equation formula. So here I see, okay, I've got a 1 in front, so it will always be a 1 and a 1. So I need to multiply 2 numbers. So it can be a 3 and a 3 that I multiply to give me 9. And it can be a 1 and a 9. Okay, so if I multiply those two together, I will get the 9, but I must also check what is in front of the t. So if I say 1 times 3, 1 times 3, I add those two, it will be 6. And I'm looking for 10. If I say 1 times 1, 1 times 9, okay, so that is 1 plus 9, that gives me the 10. So now I know my 2 points are 9, and let's just quickly turn that off. Just quickly. I just want to move that part as well. Why does that? No, I don't want to move. Okay, because it's part of the other one, so it's fine. I'm just gonna do that. Okay, so then we know the other one is 1. So t times t will give me the t square. That will give me minus 9t. That will give me minus another 1t. So we get to the minus 10t. So basically, we will know that the turning points will be 9. T minus 9 will be equal to 0, and t minus 1 must be equal to 0. So the 2 turning points is t is equal to 9, and t is equal to 1. Okay, I will make it a bit bigger. Is it the color, or is it just my total not neatness of writing? So that I just know if I need to switch color as well. Okay. Okay, cool. So let also, I'm going to see if I can quickly zoom in as well a bit more, and I can move it around. So is that a bit better? Okay, awesome. Okay, so basically we have now the one turning point is t is equal to 9. The other turning point is t is equal to 1. Now to get the other value, you need to put those two numbers into your original. So you need to now put that into the original formula so that you have T9 and whatever the other one is. So here they have calculated it, and where T is 1, so you need to put that into your original formula. So it is quite, again, a lot of work if you need to do that. So let me just, because now you need to say, okay, 9 to the power of 3 divided by 3 minus this one plus that one, plus that, and then make sure you don't make a mistake. So what I would also nearly tell you to do is, if you have access to maybe Excel or something else as well, use those platforms. You don't need to need to do it on your calculator if you can put in those things into a spreadsheet or into another tool that is online available. Again, I think this is one of those subjects that there are some other tools available. So use the differentiation calculators that are available online. Use the integration calculators that are available online. Okay, so basically with those 2 points, you would have gotten the one is there and the other one is there. So that is something that they can ask you in the exam. So what are the 2 turning points? And you get that by doing the first derivative to get to the t value, and then you need to substitute the t just back into your original formula to get the other value as well. Okay. I quickly want to ask you guys a question on your exam, and if they, so sorry, it's smaller again. I'll make it when I write. I will increase again and also write bigger. Have I told you what type of exam you guys are writing? Is it going to be a downloadable paper or is it an online exam? Online. Okay, so phew, okay, so they're now doing that as well for you guys. Okay, so that does make it different. um, so if you have what they told you how it will be, please send that to me on the WhatsApp group, or email it to me, because what what I know our stats exam was. So the stats exam was basically also 2 portions of 15 questions. You write 15 questions, you save it, and then 10 minutes later you start with the next set of questions. So I assume it's going to be very similar to that. If it is like that, the one thing that is happening with the stats paper is that when you finish with one question, you can't go back. So I just want to make sure if that is how you guys are writing as well. So it's nearly you do your first question, you save your answer, you go to the next question, and you can't go back to the previous one. So I just want to make sure that is how it will be for you as well, because then it becomes a bit more difficult in the sense that you can't just pick the questions that you offer, that you nearly want to build up the easiest ones first before you get into the more difficult ones. So just please send me whatever they have communicated with you, that I can just see how that is. Have they also given you in one of your under some of the additional documentation Okay, let me quickly see here. Okay, I'm just reading what. Okay, so do you? Okay, so please, if you have, if I do a mock exam, because I know they're doing mock exams for a lot of our online exams as well, please do it. Even if you feel you're not ready to do it, just to see how the system works and how the process works. Also ask, I see they mention here e-tutors. So please ask the e-tutors that they need to find. Okay, so did some of you guys do the mock exam? Okay, now Colleen, please unmute and tell me how it was.
I'll be honest with you and say I was trying to prep for my programming one. So I was naughty and I took screenshots
Okay, but so
that I could prep properly.
Okay, no, that's awesome. So was that some of the screenshots that you sent to a group?
No, I didn't send any screenshots.
Okay. Okay, so you can send it to the WhatsApp group as well. But so what you basically then did was you looked at it, you took a screenshot, you filled in an answer and went to the next one. And you did that with all the questions.
Yeah, I didn't actually fill in anything. I just ran through it.
Okay, so you won't know if there was a way that you could go back to the previous question.
These things are all linear now, so you can't do it.
Okay, so that is also what I've picked up, and then the other thing is what they're doing with the stats one, and they probably do it then with DSC as well, is there's not just one exam paper. So there will be like 3 or 4 exam papers that they nearly randomly give a question to you, so that the question will be nearly similar for all the students, but it will be different numbers, so that you can't use a chat to say, I've got in question 1, I've got A, because for the next student, his right answer for question 1 can actually be option C. So in any case, I am muting the chat when it is exam day and stuff like that, but just be aware of it, that it is then randomized questions, so that in the end the computer marks your exam. Okay.
Gene,
Yeah.
what I found when I did the computer programming one is it took a very long time to go between the questions.
Yes. So what I know what happened last year was, or last semester, when it was completely online, they actually extended some of the times as well. So nearly watch your, if you can, watch your emails and things like that when you do the online exam, because it can be that they see, because they can track it in the back. So
Yes.
if there's too much traffic, then it takes long. So then a lot of the time they would communicate with the MyUnisa to say, the first session is extended by another 10 minutes or 15 minutes. So just keep those things in mind as well. And if you have e-tutors, because again, with our stats one, because I'm an e-tutor there, I am in contact with a lecturer. So the e-tutors are more in contact with the lecturers, so that if they push a message to you to say, okay, there's another extra 10 minutes added. So, and what happened with the stats one last semester was, originally it was done 25 questions, and on the exam day it was made only nearly 20 or 22 questions, just because the time it took. So one normally thinks it's quicker online, but it actually, because you're working out the answer, then you need to click the answer, then you need to save that one, and then you need to go to the next question. Then it still needs to load the next question, and you go through that whole process. And I think that's also why they split it in two, so that if something goes wrong somewhere, that it's not everything that is lost. So I think that is also just why they split it into, to make it easier for the servers to handle everything. Okay.
Thank you.
Cool. So the other thing that I wanted to just show again also is, when you get that you need to break up or work out the turning points, and you sit with a formula like this, that you don't nearly, when I look at this, I'm not sure how I'm going to break it up. For that, remember just, and that is why I want to show it here, remember that there is this formula that you can use. And again, if you can, I would nearly do that in Excel as well, or I would look if there's not a way online that there is already a function like that. Because again, to do this while you are busy online on your calculator, a lot of places that you can make a mistake. So it's nearly trying to move away from where you can make mistakes. Okay, so let's quickly, I just want to see if there's anything else that I want to show you. So let's look at this one, because this one is giving you other information, and sometimes you always wonder, okay, but now they give me this information, what do I do about, or what do I do with it? So they tell you the demand and the total cost functions are, so that's given to you. So if you need to work out total revenue, it will be the simple process still of, we know total revenue is P times Q, which is the 50 minus 2Q, and that you will multiply by Q. So total revenue will then be equal to 50 Q minus 2Q2. Okay, so that we've done. So why do they give you the total cost? So they're basically giving you the total cost curve, and let me rather do this. They give you the total cost curve because they want you to do something else. Okay, so they want to work out what quantity do I need to produce so that I break even? So we know from way back study unit 4 that your total revenue and total cost, when that is equal to one another, we break even. So again, it is using way back's memory nearly to work this out. So now you will see, okay, but that's an interesting formula. It's 160 plus 2q. So those two need to be equal. And unfortunately now it's not that just the q to the power of 2 just disappears. So I like all of my equations to be positive. So I will take all of these ones to that side. So 2q to the power of 2. This side it was plus 50q, so on that side it will become minus 50q. So minus 50q plus 2q is minus 48q. And then I am left with a positive 160. So then what I will always do again is to say, okay, let's just make it base it 2 that I can get rid of. So I can divide everything by 2. So q to the power of 2 minus 24q will be equal or plus 80. Okay, so now at least it's a bit easier. Now if you wanted to, you could use this formula, but these numbers feels to me that there can be a nice answer to it. So let's see if I said before the q there's the ones. So here I'm sitting with 80, so it can be 8 and 10, 4 and 20. There can be probably other ones as well, but that's the first ones that I will try. So if I set 1 times 8, 1 times 10, it gives me 18. Okay, I'm not getting it there. 1 times 4, 1 times 20, 24. So I get the 24, which I'm looking for. So if I break that up, it will be the 2 Q's. I'm working with a 4 and a 10, a 4 and a 20. That sign is negative, so that both will be negative. A negative times a negative will give me that positive, so I am sorted. So my Q's would have been Q equal to 4 or Q equal to 20. Okay, so that would be your two quantities. And again, now what else can they ask you? They can ask you, so what was that total cost where it was a break even? Then you can just put those two numbers back into the original. So if that is what they would ask or can ask you, then it is, okay, I put the 4 into the queue, I get a total cost. I put the 20 into the queue and I get another total cost. So that could have been something that they can also ask, but I think where they would stop is to say, what was the 2 Q values? Okay, so again, basically, and I'm not going to go through this, but what we've now done is to say, well, we've got the total revenue curve. we've got a total cost curve. So if we draw it for ourselves, and that was for 0.4 and that was for 0.20. So at those 2 points, it's a break even. If it is below this, we will make a loss. And if it is above, we will make a profit. But I don't think you need to worry about this because, again, it's very difficult to ask a definition question when it's an online exam, because you can actually just Google a definition. So again, I don't see them nearly asking a lot of definition questions, but nearly the most important part is this part that you can nearly look at. And basically what this part is saying is where your total revenue is bigger than your total cost, you are making a profit. Where your total cost is bigger than your total revenue, you are making a loss. Okay, so that is basically what that diagram is showing you. I haven't seen it in any of your assignments, I think, something like this. So just if it sneaks in, but we have it then. The other one that you would have seen in your assignment. So again, when we did, what was it, study unit 4, we looked at the elasticities of demand, and then it was elasticity of demand of a linear function. So remember, linear function is a straight line function. So in study unit 4, when it was elasticity, it was the normal demand and supply function. So that is when it was linear. When we are dealing with non-linear, we are dealing with that one. So when it's non-linear, we basically are dealing with a function like that, where you have that going through, and now you need to say about the elasticity. So again, what I would do, so here is one of the functions, but also what I would do is, like I did nearly explain in chapter 4, but I'll write for you. I've got it in my notes as well that I will distribute to you early next week, is to nearly draw yourself a line again to say at which point is it elastic, and let's just inelastic or elastic and inelastic, so that it is easier nearly if you have that also next to you in the exam, that maybe there's questions that you can already eliminate. So when we go through nearly the exam of last semester, so that is my plan, to do that in the week that you write, that we do that nearly the Monday or the Tuesday, so that we next week Friday we end off with the integration, and then the Monday and the Tuesday I will ask them to create more sessions for us, so that we just go through that exam of last semester, that we just can cover everything. And then we will nearly do it in let's tackle the first 15 questions on the Monday, and let's tackle the next 15 questions on a Tuesday, that you can also nearly get the feel of the time limits and things like that that's on you. Okay, so I think again what you will see, and let's quickly look at this question, and let's look at the formula that they give us. So they say consider the demand function. They must give you the demand function. So they don't need to tell you what is the first derivative. You can actually work that out as well. So I think that is important. They don't need to give you that. So sometimes they don't tell you, and you're like, but in the examples that I worked through, they gave me that. So now how do I get it again? So basically, let's derive it from there. So we know that the 60 will fall away. The derivative of minus q to the power of 2 becomes minus 2q. Okay, so they didn't need to give it to you. You could have worked it out as well. So just that in the exam, sometimes what happens is, obviously, you press for time. You're like, okay, but I know in my other examples, they gave it to me. Now they don't. Oof, I can't get to it, but actually you can. Okay, so that you can work out from that one. Then the formula that they give us is that. So the derivative of q divided by the derivative of p. So basically, it is 1 divided by what we have worked out. Okay, so then what you can do is to say, but we have that. Look at that function, and this is where it's nearly. Okay, so that for me is the important one. So the elasticity function is basically, so you will see, and let's do it a simpler way. You would see that all that is equal to 1 over whatever you did there. Okay, so whatever your first derivative was, you basically say 1 over that. And that you will multiply by P over Q, because that is in your formula. Okay, so basically, whatever it was, 1 over minus 2Q, we will need to multiply that then by P over Q. And then we get P over minus 2Q2. Okay, so now the question is, okay, so now again, you need to be led by what is your options as in the exam. So if your option does not contain a P, you know you need to do something more. If it does have that is your final answer. If it doesn't have a P in it, you still need to replace that. But we know what P is because we have P there. So you then need to say, well, that is actually what we have there. So I will replace it, so then it becomes 60 minus q to the power of 2 over minus 2q2. Okay, so again, you need to see what is in your options, because the other option could be that there is no Q and only P's, and then it is you nearly now need to do it the opposite. So let's do the opposite. So if there's only P's in one of the or in your answers, you will then need to say, okay, but I will need to change that into something that I can replace the Q there. Okay, so then it is 50 P minus 60 is equal to minus Q to the power of 2. So I've got so much space here at the bottom, so let's just, and that is what they basically did here, is to say, okay, but I need to get to the everything in terms of Q, so I needed to replace the Q there with P. So then basically P minus 60 will be equal to minus Q2. Okay, so then you could have said, okay, but I don't like to work with a minus there. So take away the minus, that becomes a positive, that will be minus. Okay, and then you can see, okay, they like to write it differently as well. So I always also would like to write it that I don't start with a negative, so then you can write it as 60 minus P. Okay, and then the next step is to say, okay, but I'm only now wanting to get to the Q. So if I get to the Q, I need to take that, or take the square root of that. What I would have done here is I would have cheated a bit, because I would have said, there's my Q2. I've got a Q2 there as well. So why do I need to now simplify if I can just substitute it actually in there? So I would have just said, okay, well, I've got my P at the top. The minus 2 is a given. And I know Q to the power of 2 is actually 60 minus P. So why do I need to, in this instance, go to that stage if I could have done it automatically? Okay, so you would see that that is exactly the same as that. Then that would have been your final answer. They need to tell you in this instance what the value of P is. They can't now, if they want to get to the elasticity, they need to tell you up front, consider the demand function of this, work out what the elasticity is at price given 45 Rand, so that you can put in the 45 into the P. Otherwise, this would have been your final answer. So they can't ask you elasticity in this instance if they don't also tell you what the price is. So the other thing is, this was then price elasticity, because they give you price. It can be that you can also work out the elasticity of demand or of a quantity, but then we need to give you a value of Q, so that you could have put in Q into this function. So again, depending on what they're asking you, you can sit with a pricing one, so a demand of elasticity at the price of, or they could give you a demand of elasticity at a quantity of. But everything is nearly similar. It's just nearly how I now try to explain it, that depending on what you need to get, okay, so it was the other mock exam that you wrote.
Saved
So
it in the wrong folder, sorry.
okay. So basically, depending on what you need to get to, you use the same information. You can get to the pricing or you can get to a quantity. Okay, so I think that is just what I wanted to show you, so that you know there is, that you don't get caught off guard nearly when you see something in the exam that you think it's not in the textbook. So you can see in some instances they give you Q, so just be wary on the elasticities when we're dealing with the non-linear, that you can be asked to do it for demand or for the quantity and for the price. Okay. So that is nearly a quick run through on the differentiation and ways that they can use the differentiation in a few different setups. Also a quick touch on the elasticity of demand as well. Okay, so we've got time, so I want to start with the next section, unless there is a question. So let's quickly take a question if there is any. Otherwise, we can start with the next one, because then next Friday, maybe we have time to even start looking at the previous exam as well, the one that was in June that they wrote. Okay, any questions? Okay, cool. Let's go on to the next one. Let's just save this one. Okay, can you guys still see the screen? Okay, cool. Okay, so integration. So integration is basically the opposite of differentiation. So again, it is nearly, if you haven't done this for quite a while, it does become confusing. But basically, what we do with integration is we do the opposite. So if my original formula was x to the power of 2, and I would have differentiated it, I would have said, okay, the 2 goes in front, so I get 2x, and that would have been 2 minus 1. So basically 2 minus 1 is 1. So that tells me that would have been my differentiation. So with integration, we basically must use this to get back to your original. So whatever have been differentiated, if we integrate it back, you will get back to your original formula. So that's why they say that integration is basically the reverse of differentiation. Okay, so how do we do that? And that nearly for me is, so if one of these is easier. So if I differentiated x to the power of 2, I got 2x. So now I need to integrate. So the integration process works that here is a 1. So I will need to add to that 1. Okay, so I will need to add 1 to it. If there was a 2, I would have added 1 to it to get me to the power of 3. Okay, so we're basically sitting with 2x to the power of 2. Which is not what we have there. So the next step that you need to do is whatever this value is now, you need to divide it by it. Okay, so you don't do anything to that 2 because we don't know if there was something else in front of it that we got into the 2. So the 2 stays there. But what is here, you will divide by. So then you would see that I divide 2 by 2, so my final answer will be 2, or x to the power of 2, sorry. And you would see that that was the similar one there. So let's, while we're on this one, let's say I had, my original was 3x to the power of 2. So just a bit different. There's a constant in front of you, so that I just want to show you that principle. So when we differentiated this, it would have been 2 times 3, which would have given me 6. 6 x, because it were 2 minus 1 would have given me that there's a 1. Okay, so 3x to the power of 2, if I differentiate it, it gives me 6x. Okay, so now I need to integrate that back. So by my process, you have a 6x. You basically add 1 to the 1. So that would have given me 2. And then I need to divide by whatever is there, which is the 2. So then it is 6 divided by 2, which gives me 3x to the power of 2. Okay, which is what we had originally. Okay, so just nearly want to show how we do it. Yes, it becomes more difficult as we go into the different sets of rules and those kind of things. So yeah, okay. Happy with that at this stage? Okay, cool. Okay, so again, most important one is integration basically reverses differentiation. So let's go into a few examples. Okay, so there was actually one like that. So I don't think we need to do any of these as examples, but let's look at I'm gonna just want to check the next one. So let's look at one. So if okay, so let's say that was my original, and I differentiated that one. I would have said 6 goes to the front. So so 6 goes to the front, so it will be 6 over 5. It will be x to the power of 5. Okay, so that would have been my differentiated number. So now if we need to integrate, I keep the 6 over 5. I say 5 plus 1, and I need to divide everything by 6. So 6 over 5 divided by 6, if you 6 going to there once, 6 going to there once, you basically have a 1 over 5 x to the power of 6 again. Okay, so nearly just to want to show you that even with a fraction in front of it, you follow the same principle. Okay, so what we actually have done now, it's very similar to what we call the power rule. So, and the power rule is given here as a formula. The one interesting thing about the power rule that we need to remember, and let's take something like, so say that was my original formula and I differentiated that. So if I differentiated that, it would have been 6, 2 times 3 is 6, x to the power of 2. That is a constant, so that would have fallen away. Okay, so now I'm sitting with this formula. Now if I integrate that back, easy, it's the 6x. The 2 plus 1 gives me 3. I will need to divide by 3. Easy, so 6 divided by 3 does give me the 2. And I have my 2x to the power of 3. But what I don't have is the 5, because I didn't know there was a 5, because when you differentiate a constant, it disappears. So what they've brought into the rule is to say, but let's just assume that there could have been a constant. We don't need to know what it is, but let's just assume that there could have been a constant and we put in a C. And that is just so you would see in some of your assignment questions where they gave you something to integrate, that, and you need to be very careful with that in the exam as well, is what they could have given you in the exam is to say, you have this formula, integrate it for me. And they give you 2 of the 4 options this is one of our options. And this is the other option. Okay, and it looks very similar. You would have done that and you would have gotten that and you would automatically go to the first one. But remember, because of a definition, we don't know. So because we don't know if there was a constant, just add the C. I think there was in some of the assignments now, there was 1 or 2 questions that was like that. So just please be aware of it, that in the exam, please, there would be an question on this and they would in one have a C and in the other one don't have a C. Okay, so just be careful about that. And the reason is just because we don't know. Okay, we've got a few minutes left before we go on happiness up until now. So this is basically the power rule. And again, hopefully they would have given you already some information about if they're going to give you formulas or not. Don't worry, you have it in any case, and I will put all the formulas together. I'll scan it in and I'll send it to you next week as well, some of my summaries. Okay. So let's go to some of the other ones, and I think that is also important is within the power rule, there are always, how to put it easily, a bit more difficult ones. And I think that is, there's always the easy one, which is the standard one, and then they throw in a few extra things. So the things that they are showing here, and I just want to see if there's actually an example of something like that. Otherwise, we'll just, so what they are trying to show here is, so if you have a constant in front of the formula, you can actually move that constant out so that it stands in front of the whole integration that you are doing. So if you had a formula, now let me go back to, so if you had something like that, you could take out the and even, let's even make that okay. So you could have done that, and that 3 then would move in front, and you will only integrate the rest of a question. Okay, so that is just what this formula says. If there is nearly a constant that is in both, you can do that. Even if it was, I now took it out, but I could have, even if it was that. So let's say it was that. You could have taken out 3x to the power of 2. What's left is x plus 2. And that part would have gone in front, and you will only integrate that. Okay, so it is nearly, you can, in a sense, simplify that formula or that you get and with something that is in both of them, and it can be taken out of a whole integration process. Because in the end, you would have just multiplied it into it in any case, so make it simpler for yourself. Okay, so that is what this one is doing. So it is just making your life easier. What this one is showing is to say, if I needed to integrate one function that I added to another function, so if I needed to integrate that, I could have said, okay, well, we integrate that one and we integrate that one. Okay, so you can split it and you can do the one first and then the second one. Okay, because it is separated by a plus, you can do it. If it was negative, you could have done it as well. So no problem in that. You can basically split it up and do the integration of the one and add it to the integration of the other one. Okay. The other one that is very important. So we've seen if you had 1 over x, it would have, and we differentiated it, we would have gotten ln of x. So now the opposite is also true. If we integrate ln of x, okay, so let's rather do it the other way around. And here you must be very careful nearly, and I'm nearly want to say, when you look at this, so if we integrate that, it will become ln of x. The reason why they have the absolute value is because I think you can't get a negative value for ln. I'm not sure. I will just check for you that. But again, remember with integration, we don't know if there was a constant or not that disappeared. So we just need to remember, even with something like this, we need to add the c. So we need to add the constant to it. So every time, just be very careful when you do that you need to add the c. The other one that we will end off with is the exponential function. So exponential function, and this is one of the easiest ones, it stays as it is. So if you integrate that, it will stay that. Okay, but remember, again, only if it's the normal EX. Again, you will need to add C. When it is that, it is not the normal natural exponential function. So when we have that, we will need to do a bit more, because then it becomes actually two formulas because you've got the E and you have that. So you will then need to do replacements again, like we did in differentiation as well. Here you would do the same. So just remember for the exponential, it is where it is the simple EX and not anything else. So if there's anything else with that X, we can't just do it like that. Okay. And that is where I want to nearly stop today. Next week, I will finish off with all of this, so that the week after we can do nearly another 2 sessions. I think next week is going to be a long session, so prepare yourself for, I think, a 2-hour or even longer session. We will take a coffee break in between, so don't worry about that. But next week will be a long session so that we can finish off everything. And then I think you're writing on, I've got the date here on the 12th. I think that is the Thursday. So I want then us to basically look at the week of, so the Monday and the Tuesday, to go through some exam prep, that you at least have a Wednesday to still do it, and then write on the Thursday. Okay. So that is it. Eva, I think you had issues getting into the team site today. What will happen is this session will be available on Monday. Hopefully, maybe because there's not a lot of sessions running at the moment, so maybe they can do it over the weekend. But I think most of the sessions for some of our other subjects end over the weekend. So hopefully early next week this one will be up and we'll be able to listen to it. And then what they normally do with those last 2 sessions in the week, they would assist me very nicely in getting it to you nearly as soon as possible. So yeah, so that 9th and 10th, they normally then make it sure that the session on the 9th nearly is available late that evening on the 9th or early morning of the 10th and something like that. So nearly you will get those last 3 sessions in a day or 2. Okay. So that is it for this session, guys. I'm going to stop the recording. If there's anything that anybody quickly want to ask,